Hello everyone, this is Ray Savage with Cambium Networks. Thanks for joining us today for this special webinar that we have on the ePMP field performance. And I guess just looking at the first slide, you can see that we're going to get right to the point of ePMP versus Ubiquiti. The presentation is being recorded and it will be posted to the Cambium community and YouTube later today. But if you do have any questions during the course of the presentation, please use the question and answer dialog box on the right-hand side of your screen, and we will present your questions during the course of the presentation. Well, our special guest presenter today is Mr. Chad Wachs. He is the president of AU Wireless, and he's here to share his field experiences, and all the Cambium folks will just sit back and listen. Chad, over to you.
Thank you, Ray. Appreciate that. My name is Chad. I am a member, kind of the founder of AU Wireless. AU is the elemental symbol for gold, and our ISP happens to be located in Golden, Colorado, so that's kind of where that name comes from. So what I'm going to share with you guys is just a little background on myself, our organization, and then kind of detail a couple months long process we went through when selecting a hardware vendor for a brand new ISP that started off with some Ubiquiti tests and then ended up with some Cambium ePMPField tests, and share those results of what we found in our environment. I don't want to make it a competition between Cambium and Ubiquiti. I know they make some good gear, and there's thousands of ISPs out there making very good livings using their equipment, but I'm just going to kind of share what we found in our particular environment. Next slide. So I spent the bulk of my working career as a broadcast engineer, so that is my background. Most of that was done in the sports industry, where I worked for Fox and ESPN. But moving video and audio files around an IP network is not much different than moving email files around. So I became pretty well versed in the IT side of things and infrastructure and networking. I have done a lot of work with Ubiquiti equipment. I've been involved in some fairly large deployments of that, kind of as a side job with a good friend of mine. I've also done some pretty big point-to-point deployments with Ubiquiti for a municipality with my current job, building a backup wireless network to some fire stations in a city outside of Denver. In the kind of late 90s, early 2000s, I was involved directly in the ISP business. I founded and ran a company called LoftNet. This is pre-DSL, pre-cable modems. We worked in the MDU space, primarily with high-rise residential buildings, bringing in fairly large lines into the basement and then reselling that stuff inside the buildings before you could get a DSL line. We had offices in Denver and Chicago, and then unfortunately all of our backers went down with the stock market when it crashed in the early 2000s. We were not yet out of the red, so we ended up folding up with them. So these days I make my living as a full-time firefighter, so keep that in mind when maybe you look at these field tests and you say, "Ooh, that was kind of a strange way of doing things." That's not my full-time job. So next slide. We are a CoOp ISP, and when you look at kind of what we're doing speed-wise, providing to our members between 25 and upwards of almost 100 megabits, you'll look at that and say that's not a sustainable business, that no ISP can make money doing that. And while I believe it to be sustainable, I fully understand that that's not a business, and that's not what we're trying to do. We are trying to provide an alternative to either DSL or cable, depending upon what the members have got in our town. We want to keep the speeds fairly comparable with that, but we're not looking to make money as this. It's a co-op that is run and managed by the members themselves. So as a result, the subscriber base is fairly low, and it's going to be low and remain low on purpose. We serve a town of about 20,000 residents. We do have a pretty large engineering university in here. We are geographically isolated from Denver, which has been kind of a good thing. We've got, you can kind of see from one of those pictures there, we've got mountains surrounding most sides of the town. That's also protected us RF-wise from what's going on in Denver. And it was just really myself and a few other members that were getting fed up with the internet options that we had in town and dealing with the large telco carriers, and wanted to try something new, and that was kind of the birth of AU Wireless. Next slide. So it allowed us to not have to support any legacy equipment out there at all. We started from ground zero and wanted to find the best possible gear to provide the speeds that we wanted to provide to the customers. And our members are in an area in the neighborhood of about a mile to almost 4 miles from where our tower is located. The tower sits about 1,700 feet above the town, so on the western border of Golden is a mountain that has every single broadcast tower for the Denver metro area for television and radio. That became a blessing and a curse to us. The curse is we are surrounded by FM. Pretty much every FM radio station in Denver is within 1,000 feet of our tower. So I learned pretty quickly what FM interference looks like on long Ethernet runs. The good news is tower space is relatively inexpensive. It's high up, and it looks over our town very well. So when we started this, I initially thought in my mind Ubiquiti was going to be our vendor because I had experience with them. I used them. I knew their software. I felt comfortable with them. So we ended up purchasing some of their equipment to start the test. Built a point-to-point backhaul from a fiber location we had in town using Mimosa gear up to our tower, and then began our field tests. Next slide. So we first got a Rocket 5 AC point-to-multipoint into one of Ubiquiti's 60-degree sectors. We bought a couple nano beams and then the power beam. For those that may not be directly familiar with their product line, what you see there in that picture, that's one of the nano beams. It's a 19 dBi gain, small form factor, CPE. Their specs say that that thing's good out to about 20 kilometers. You talk in their forums and people will tell you it's really good to about 500 meters. But we wanted a small form factor AC CPE, and then the power beam is really more like a Force 110 or the new Force 200. And it's also got RF ISO built-in, shielding built-in around it as well. So we bought those, added a few test subscribers, and then I built kind of a mobile setup where I put a couple of these CPEs on a tripod, got in my car with a laptop, and drove to a couple dozen sites around our RF footprint to start doing some field tests and see how these things performed. Next slide. So right off the bat, we ran into firmware issues. And while the AC equipment from Ubiquiti has been out for over a year, and it has stable non-beta firmware, you're pretty much living in a beta world with AC gear. And like anything else when you're using beta, you immediately get issues with different beta versions not working with each other. We were constantly upgrading to the latest beta that would add new features that we didn't have. It would fix things that were broken, but then it would break things that were working in previous versions. So you can kind of only handle that so long before you get just fed up with constantly dealing in the beta world. Primarily, though, our issue was the throughput was much lower than what I was expecting with AC gear. And it wasn't as reliable as I'd seen in my previous experience with Ubiquiti stuff. We started off doing the tests where we had just a single CPE running around doing these RF tests, so it was really almost a point-to-point. As soon as we added any additional users on top of that, everything kind of slowed down, and that didn't really make a whole lot of sense with us. We were not able to get clients to connect reliably beyond about 2.5 miles. Even though we got decent signal strengths, things just weren't locking up. And when we did speed tests, we were feeding our sector with a 100 megabit symmetrical line. When there were no other clients on that, we were still only really seeing about a 50% throughput rate from speedtest.net based on what the radio told us we should be getting for that location. Next slide. So we started looking at other vendors. We tried some LEGO Wave equipment. We tried some Microtik equipment. And I kept hearing Cambium's name get mentioned over and over again. We found a supplier, a vendor here in town that has worked with Cambium and was able to get us some loaner gear to duplicate these field tests. So what you can see there, that's our little test rig. That's my car. That's got a Force 180 and a Force 110 sitting on it that I would drive around, redo all the tests that we did with Ubiquiti. Deployed an ePMP 1000 GPS with the 120 degree Cambium sector. and then again duplicated all those tests where we had done with the Ubiquiti equipment. So next slide. From the very beginning, what I found was the Cambium stuff just worked. Every time we'd fire up a CPE and point it up at that AP, it would lock up. It would give me great signal to noise, and we would get excellent throughput with it. We are running currently all of our APs in flexible mode. I know that's going to be a problem down the road for us if we do end up growing, but we needed to get, one, the maximum throughput, and two, at this point, all the APs are pointed in the same exact direction because this antenna is high up on one side of the town. So it's something I'm going to follow up with Cambium later on, where we're just not able to get much speed when we get into a synchronized mode. But what we were seeing with the Cambium gear was fantastic signal to noise that was typically 8 to 10 dB better than what we were seeing with Ubiquiti in the same exact spot. And the Force 180 really impressed us that it was working out upwards of 2.5 miles from the tower and performing very, very well, where the little power beam from Ubiquiti would kind of fall off after about 1.5 miles. The speed test to the internet would mimic what we're seeing reported from the radio itself. And here's a picture of one of our clients sitting at about a little over 3.5 miles out using a Force 110, and the 20 megahertz channel is getting pretty much the maximum bandwidth that AP can provide him. And that was something we were never able to get with Ubiquiti in that same spot. Next slide. One of the immediate problems with having a tower 1,700 feet above your town is your vertical beam width plays a big role into what your footprint's going to look like. And particularly with the Ubiquiti sector, it's got an extremely narrow vertical beam width. And we were looking at anywhere between 10 to 15 degree mechanical down tilt on these. We were pretty low beneath that tower, and so it really reduced our footprint and was going to require lots of sectors up there to cover the town. So when we started looking for antenna options, we got in touch with RF Elements right as the twist ports were coming out. They agreed to put us in the beta program for them because they kind of liked what our town looked like from an RF standpoint and wanted to get some field tests from us. So they shipped us a couple 60-degree horns and an adapter for a ePMP as well as the Ubiquiti, and then sent us a spreadsheet where we needed to go out and kind of document all these metrics across the town for their data and for their marketing purposes. What this did for us is it gave us kind of the decision hardware-wise the information to back up the decision as to what we wanted to go with for our co-op. And we tried as much of an apples-to-apples comparison with CPEs. And again, we've gotten a fair amount of grief in some of the forums about trying to use the power beams and how they're really only good for well under 1 mile, despite the fact Ubiquiti's marketing material will claim they'll go out to 21 kilometers. But we felt like what we had was a pretty good comparison with the Force 180s and Force 110s to the power beams and nano beams from Ubiquiti. Next slide. So this gets a little bit busy, and I'm not expecting everyone to read this, but this was one of the sheets that we came up with using RF Elements data. The top portion of it there with AP2 is what we got using the Rocket 5 AC. The bottom section with AP1 is what we had with the ePMP, and this is looking at this with sector antennas. So we went out, did a couple dozen field tests with each product into the sector antennas, and then went out and redid all those field tests using RF Elements twist ports. But what you can see is each different colored line there is a product-for-product comparison from the same physical location. So that top one in yellow, we're looking at the nano beam and the power beam. So every location was done with both CPEs. We were not able to get reliable connections from that location with Ubiquiti's gear. Then you jump down to where we've got the Force 180 and Force 110. We're pulling in between 70 and about 85 megabits from that same location using ePMP's gear. So once we did this and started analyzing the data line for line, location for location, and again, all of this was within the predicted RF footprint for both antennas, it kind of told us that in our RF environment, with what we're trying to achieve, the ePMP product line was going to perform significantly better than the Ubiquiti product line. So that ended up kind of helping make our decision go in that direction.
Excuse me, Chad, we did have a question come in, and it was from one of the network operators out there, and he said, during the testing, did you ever contact either company for technical support to make sure that everything is set properly?
Yes. Not only did we contact the companies, but we also contacted, we worked pretty closely with the local vendors that have got a fair amount of experience with both of them. Both of our local vendors for both product lines were former WISP operators that then turned into hardware vendors, so we felt like we had pretty good technical support on both sides. We've had people from the company log into our APs, verify settings, send screenshots back and forth, and I asked a lot of questions in the forums as well. And that kind of came to a point that we were talking about before we went on here, that I want to thank those in the Cambium forums, because I have found them by and large to be a very friendly, snark-free environment for those, especially like myself, who has not been in this business for decades, asking questions and getting very helpful answers. That it's refreshing to have that. I've spent a fair amount of time over the last decade in the Ubiquity and in Microtex forums, and you don't always get the help you're looking for, but Cambium's got a little bit different attitude that we found that's been very helpful to us.
Well, thanks. We appreciate that. And apparently your chart that you've got up is very high resolution. People are able to read it, which is a good thing. And here are a few questions that we got on it. That'll give everybody else a few seconds to look at the details there. This network operator says that these tests are all done in flexible mode. Is that correct?
That is correct. We did do tests in synchronized mode. We found that we just weren't getting the throughput that we wanted, so these tests here represent flexible mode, yes.
Okay, and what are you able to share any results that you did when you were using synchronization?
We did not spend as much time in synchronization. We weren't as thorough in synchronization. We tested it from a couple different locations, and it's one of the things that's on my list now. We've just put a new test AP up on our tower, and I'm actually planning on redoing some synchronized tests because I want to get back with you guys. What I was finding from a synchronized standpoint, if I was looking at like the 7525, I was barely able to get better than about 45 megabits. Where when I put that same AP into flexible mode from that same location, I jump up to 120 megabits downlink. So I think something must be going wrong on my end. I'm not getting the results that I think I need, so I need to do some further testing myself on synchronized.
Okay. We have one other question, which was, did you verify the antenna tilt on the equipment? Because sometimes if the tilt is off, it can really skew the results.
Absolutely, and I have spent more time than I ever wanted climbing up a 100-foot tower on top of a mountain in wind, changing tilts. One of the things we did to verify tilt was we would kind of go to what we believe to be the bottom of the tilt pattern, verify signal strength, move closer in, make sure it dropped off, and then repeat that at the top of what that tilt pattern should be to kind of prove to ourselves that what we thought the predicted tilt would be was the reality, and so yes, that stuff was verified.
Okay, thank you. And when you were talking about doing tests with sync, we have one network operator that says, based on your comments, it sounds like what he's seeing with synchronization, he's going to go ahead and do tests on flexible mode in the field and share the results. So we'd appreciate it if you'd put those results up on the community, and we'll talk about the community in a little bit.
Okay. And when you're
ready. Okay, Chad, are you ready for the next slide?
Yeah.
Okay.
So where we are today, we've got 3 ePMPs up on the tower. 2 of them are in 20 megahertz. 1 of them is in 40. Again, because we are providing those higher bandwidth packages. We've got about 16 co-op members. Right now we're adding in the neighborhood of 2 to 3 per week, and that's kind of also dependent upon how much snow. Right now I've got 2 feet of snow on my roof, so it's not a very good time to be going up and putting new customers on. We're going to remain small on purpose. Again, this is not a sustainable business model. This is almost more of a hobby for what's going to end up being a few dozen members of this town that are just looking for a better, more reliable faster internet alternative. And we're a town that is very community driven and likes to keep its money inside the town. There's a lot of small businesses here, and so we've got a couple people that have told us, look, I got no problem with my current cable connection. It's fast, it's reliable, but I would rather give my money to a local company and help start up something like this than give it to them. So we've been very happy with what we've seen with Cambium and look forward to using their gear in the future. So hopefully this has been helpful to some people out there.
Yeah, absolutely, Chad. And we have one more question about your test results, and that was what channel or frequency was being used for your test results?
Yeah, good question. We used, if you want to go back to that slide, it may actually be on there.
Yeah, there we are.
Nope, I cut that column off. The ePMP stuff was down at in the 5.2, I think 5240, if memory serves me, was the specific for that. And then the rocket was not able to go down into that lower band, so it was on what ended up being a clean 20 megahertz channel at in the 5.8. To make sure that I was really doing an apples for apples, we did end up moving the ePMP up to that same frequency that the Ubiquity was on, redid a handful of the tests just to verify that I wasn't having interference on the Ubiquity side. The tests were identical in the 5.8 as they were in the 5.2 for the ePMP stuff.
Great, and we appreciate you sharing the information, Chad. Certainly, if anybody has other questions, go ahead and put them in the question and answer box. But also joining us in the studio today is Sakit Ahmed, who's the Director of Engineering for ePMP. And Sakit, I guess, do you have any closing comments for folks?
Well, I just wanted to elaborate a little bit on one of the questions that came up about the synchronized mode of operation versus the flexible mode of operation. We do have a ton of documentation on it, but fundamentally, I just wanted to explain that when you are running in the synchronized mode and you choose a particular uplink downlink ratio, that essentially means that the time in the air is divided by that ratio. So if you are able to send data down and it's 75-25, that means only 75% of the capacity is being used, not the whole 100%. In flexible mode, it's exactly what it says, it's flexible. There is no fixed ratio. So we use up as much of the air time as possible in one direction and then reverse it to the other direction. And the reason for the uplink downlink ratios in the GPS mode is because you're trying to synchronize multiple access points across a tower or across multiple towers. So when they're all talking at the same time, they're all synchronized to talk only 75% of the time and then come back and listen 25% of the time. This prevents the overlap of transmit and receive. So you'll always see a difference in performance in GPS sync mode versus flexible mode, but it's only because you're trying to synchronize networks and you're locking down the transmit and receive. Our recommendation typically is that if you are deploying one sector or you're not really looking for synchronized base stations or access points across a tower, multiple towers, you use flexible mode. Anytime you're trying to do frequency reuse, you go with the synchronized GPS mode.
Great, thank you, Sakit. Well, I just want to remind everybody that you can keep up with the latest information on all of our products, including ePMP, by following us on social media. And one of the things that Chad mentioned is our community, which is a free resource that's available to anybody. You just go to community.cambiumnetworks.com, and there you can find information on ePMP or any of our other products, network planning and link planner, business issues. We also have a knowledge base with certified information from our technical support team. And obviously you can submit your development ideas. Let us know what you think we should be looking at next, and we do review those suggestions as we go through the development process.
I also want to add that along with that, if there are other topics of webinars, I don't know if you mentioned that, we are always welcoming new topics for webinars. If it's technical topics, particular feature, troubleshooting, if there's a particular topic that helps the audience, just shoot us an idea and we'll definitely execute on that.
Yeah, and you can send that to solutions@cambiumnetworks.com, or if you go to the website, there's a contact us page there. Well, Chad, on behalf of our audience, I'd like to thank you very much for your time and work. And for everybody that tuned in, thank you very much. And we look forward to seeing you on the community and on future webinar. Thank you very much.
Thank you.